You spent years as software engineer solving problems, debugging systems, and shipping code that makes money for your employer. But now everywhere you look, companies are hiring AI engineers, some making double or triple your salary. So let's be honest, in your heart, you want to become one of them. And the question that keeps nagging you is, are all my skills already outdated? The answer is no. You already have the engineering foundation. What changes is how you apply it. But we also have to realize that the role of an engineer in AI looks different from what you are used to in terms of the mindset, the tools, and even how you measure success. So in this video, I'll walk you through the 6 transformations that you need to make to jump from software engineer to AI engineer. Each one comes with a real-world example you will recognize and a tactical skill you can start practicing today. By the end, you will see exactly how to evolve into this new role without starting over. I've been building and working in tech for over a decade, and I've made just about every beginner mistake you can think of. My goal here is to share the shortcuts I wish someone had handed me when I was starting out. So whether you are preparing for your first job or looking to grow in your career, subscribe so you can get the real world advice that you can apply right away. Let's start with the transformation number 1 you need to make. As a software engineer, your job has always been like building a car. You design how the gears fit together, you tighten every bolt, and you make sure nothing moves until you have written the exact command for it. You control every single part of the machine. But in AI engineering, the car already exists. By that, I mean the foundation models such as GPT, Claude, Llama, Gemini, etc. These are the engines trained on massive datasets with thousands of GPUs. Your role now isn't building the engine, it's training the driver. The model has raw capability, but it doesn't automatically know your rules of the road. It needs to be steered with precise instructions adapted to your quirks of data and given access to the right tools so it can act inside your system. That's why prompt design becomes the steering wheel. The way you phrase instructions directs the model's behavior. Fine-tuning is how you teach it the local streets, giving it your company's language and the edge cases. And tool access is like the pedals and the GPS, letting the model do the real work instead of just talking about it. So the takeaway, you're no longer coding every gear shift yourself, you're creating the training and the guardrails that shape how the driver, the model, behaves once it's in motion. Now, just like you're no longer building the same thing, your toolbox also need to evolve. And that's your transformation number 2. As a software engineer, your tools have always been like calculators. They were precise and predictable. You pressed the right buttons and you always got the same answer back. But in AI engineering, your tools start to feel more like junior assistants, sometimes brilliant and other times completely off the rails. If you ask for help and they might draft something very impressive or might scribble complete nonsense with full confidence. You can't just use them, you have to supervise them. That means your relationship with tools changes. AI coding assistants like Copilot or Cursor can accelerate your work, but they won't replace your judgment. Reviewing and editing their output becomes part of the job, the same way you've double-clicked an intern's work before sending to production. The shift is simple. Calculators give answers, assistants need guidance, and your job is to manage the intelligence, not just consume it. But what about the results? That also changes meaning, and that's your transformation number 3. By the way, if this is helping you out, please like and subscribe. It tells me to make more videos like this, and if you've got a question or a different take, please drop in the comments below. I'm always curious to see what you think. In traditional software, success has always been binary. Your code either passed the test or it didn't. It was like a stoplight. Green means everything works, red means it's broken. Simple, clear, and absolute. AI engineering does not work like that. Success here feels more like a weather report. You don't get a guarantee, you get probabilities. A model might answer correctly 80% of the time or generate summaries that are good enough for most cases but miss the mark in edge situations. That means you need to stop asking, is it right, and start asking, is it reliable enough, often enough for this use case? Instead of one red or green light, you are tracking averages, error rates, and confidence thresholds. Think of a fraud detection system. If it flags 8 out of 10 suspicious transactions, that sounds great. But if the 2 it misses cost millions, the product fails. Or imagine an AI summarizing customer chat. If it's accurate 90% of the time, that might be fine for internal notes, but nowhere near acceptable for medical records. So the big shift: software engineering judges correctness, AI engineering judges performance under uncertainty. But things usually go wrong and you're called to troubleshoot or debug. And that's your transformation number 4. As a software engineer, debugging is mechanical. Something breaks, you trace the error, swap the faulty part, and then the system runs again. You are the mechanic under the hood. But with AI, bugs don't always leave stacked traces. Sometimes the model calls dog a fruit or invents a fake fact with super confidence. In AI, the code is usually fine. It's the behavior that is off. Debugging here feels less like a mechanic and more like a detective piecing together all the clues. So instead of asking what line in the code crashed, you are asking, why did it act this way? Maybe the training data was biased. Maybe the prompt was too vague. Maybe the model lost track of context after 2000 tokens. You gather evidence, run small experiments, and test different angles until you uncover the cause. Now picture building a customer support AI system. A user asks, how do I cancel my plan? And the assistant replies with upgrade instructions. The error isn't broken function, it's misinterpreted intent. Fixing it might mean rewording the prompt, adjusting context windows, or supplying better examples. But what about your method of building products? That also changes, which is your transformation number 5. And hey, if this all feels a bit overwhelming, I get it. I've been right where you are. That's why I put together a free guide and worksheet to help you figure out the best role for you and prep without wasting weeks on stuff you don't need. Grab it from the link in the description. It's totally free, and honestly, it will save you a ton of time. Traditional software development feels like an assembly line. You gather requirements, design, write code, run tests, and ship. It's linear, it's predictable, and once the product is out, you move on. AI engineering feels more like working in a lab. You mix ingredients, data, prompts, model, observe the reaction, tweak, and try again. It's experimental, not linear. Take building a recommendation system. You don't write one perfect algorithm and call it done. Instead, you try model A with prompt style X, then model B with slightly different data, and so on. You compare results, learn what works, and then iterate. You need to track what's changed: the prompt wording, the model version, the training data. Otherwise, you won't know why performance suddenly improved or broke. On an assembly line, consistency is the goal. Identical products rolling out one after another. In a lab, you expect messy prototypes and failed experiments because each attempt teaches you something new. Now, you already know the data is important, but as AI engineer, your relationship with data also changes, which is your transformation number 6. In traditional software, data is like batteries. You plug it in to power the program, but the logic still comes from the code you wrote. The data just flows through. In AI, data is the fuel. It is the logic. The quality of the data determines how far and how smoothly the system runs. Feed it junk and the model behaves like an engine with watered down gas. Picture a customer support bot. If you train it on outdated FAQs, it will confidently give wrong answers. If your dataset is messy, has duplicate entries, missing labels, the model learns those mistakes as if they were facts. On the flip side, when you clean and curate the dataset, the same model suddenly sounds smarter without changing a single line of code. That shift means engineers need new habits, spending as much time refining the data as they once did refactoring the code. It's cleaning, labeling, and organizing information so the system has high-octane fuel to run on. The mindset change is simple. In software, data powers the program. In AI, data becomes the program. Understanding the transformations gives you a good sense of the changes you need to make. But here is the catch. Knowing these shifts is only one thing. Turning them into actual skills is where most aspiring engineers will struggle. And that's why I put together a step-by-step roadmap to becoming an AI engineer that gives you clear blueprint. I encourage you to watch it. See you there.